Hello, everyone. Welcome to this webinar. It's a pleasure for us to have you all here. I hope that you're having a good day, and we're going to begin. I would like to remind everyone that this webinar session is being recorded, that for respect and courtesy to all of our other attendees, we recommend you and ask you to please keep your cameras and your microphones off. And if you have any questions, you may send them in the chat. We will try to answer all of them at the end of this session. Okay, once again, my name is Fernando Rico. I'm responsible for the sales channels in the Americas. And today we're going to be talking about FOTRIC acoustic cameras and how they help users in different industries to stop guessing where leaks, bad bearings, and partial discharge are located, how large, how bad, and what type they are. So let's begin. When we look around in the industry, we see different products designed to find leaks. These videos that I'll show you now are pretty much the examples that are used for either training or advertising of different brands. You will see the amount of different attachments that exist out there to try to perform one single task, to find leaks. Long distance, short distance, trying to identify where the leaks are using lasers, concentrating devices. So try to identify the specific location of an issue. You can see in these two videos that there are lasers being used, which means that you get to listen exactly what it is at the red dot, but it also means that you need to follow every part of the pipeline, every connection, every valve and gasket to identify whether there is a leak or not. Something that really calls my attention on the video on the right side is that it actually shows how things are done. There is one person holding the listening device with a parabolic antenna, headphones on, and there's a secondary person taking notes of the asset, the specific component of the asset, and perhaps the decibel readings. There are many devices out there that are pretty good, to be honest. They're very accurate and they're very sensitive. The only issue with this type of technology is that it requires more time and it requires something that is called from gross to fine approach. We're going to talk about that in a moment. This is how it looks on a similar setup to find a leak with a FOTRIC acoustic camera. Moving the camera around, it doesn't matter the position or the angle, the camera remains locked on to the specific spot where the leak is located so that instead of performing a scan on every single part of the red pipeline, you're able to see where the leak is located. You can also see how noisy this environment is. You can see all the different frequencies of audible and ultrasound showing high peaks of intensity. These are completely filtered out by the camera to concentrate or focus on the actual sound signature of the leak. For the ones that are not quite familiar with acoustic cameras yet, an acoustic camera works in the similar way that our ears work. We have a pair of them on each side of our heads, which allow us to identify whether the sound is coming from one direction or the other. Acoustic cameras do that, but not with two, but with up to 234 microphones that combine the triangulation power with a digital camera, which allows them to build a sound map on top of the digital image to locate the actual source of that ultrasound. FOTRIC cameras use a very specialized electronic component called an FPGA. We use one of the top suppliers of that specific component, Xilinx. This is an American chip manufacturer that allows us to process that data simultaneously from all microphones without using higher power. And that is very important because that is giving FOTRIC an edge on how the technology is developed and how the equipment performs in the field. These other two videos are very interesting. This is one of the most popular listening style ultrasound devices out there. And these are fractions of their training videos on how they recommend to find leaks. This is what they call the gross to fine approach. You move the equipment around like you're moving a magic wand, trying to pick up for something. And once you start hearing something, you try to adjust the sensitivity, you try to get close to the area, and see how much time it's taking in both videos to find one single leak. And if you are listening to this webinar, most likely you're one of our partners and you have promoted our products. And you probably have heard the question, can I adjust the sensitivity of the camera? And you wonder, but you're already seeing the leak. This is where it's coming from. In this type of devices, it is recommended that you go from high sensitivity to be able to hear something on the first place to later do lower sensitivity when you're closer because it will be really, let's say, annoying or deafening in some cases to listen to a leak when you are right in front of it and the sensitivity is high. One more interesting thing here is that it is required to back up 12 to 15 inches, which is roughly 30 to 40 centimeters from the leak, to be able to capture the decibel readings. Now, let me ask you, what do you do when you are dealing with an overhead compressed airline that is several feet above you, several meters above you? How do you stand back and, capture from 12 to 15 inches when you're in a substation? These are some of the hurdles that this type of technology used to pose for users in manufacturing facilities and substations. And one of the reasons the learning curve was so steep and it will take days just to be able to manipulate a unit like this. It was completely listening based and it made ultrasound a very niche job inside the plant that only one or two people per plant could perform. You can tell now why, how difficult it is to get to do something very simple. And a lot of these products will sell more on training than on the device itself. And that is what FOTRIC cameras are doing. They're changing the game because getting to use them is completely easier. On this video that I'm about to show, I would like to suggest one of those scenarios where using this type of devices and trying to guess and trying to locate will be completely difficult. During this demonstration, I provided two acoustic cameras to users that had never used one. And we visited this stacking cell within the factory. And you can see here the robotic arm that works completely with pneumatic systems. And specifically here, it is using vacuum to lift the cardboard that goes at the bottom of the pallet before the packages are stacked. You can see that the camera follows the vacuum leak as the robotic arm moves around, something that would be completely unachievable using a listening gun style acoustic device. The same goes with, as I mentioned earlier, overhead pipelines and robotic arms. Something that by having an acoustic camera, it is a job that is done much easier, much faster. That's what an acoustic camera by FOTRIC is designed to do. It is meant to provide agility. It is meant to eliminate the guessing by trying to listen for louder or quieter noise. It is designed to bring efficiency at identifying leaks and especially those that are harder to find. Here's another application, not talking about compressed air leaks anymore, but talking about electrical applications. We recently performed a demonstration where the customer saw the camera at the office and immediately told us, we would like to test this on site. Are you guys willing? We agreed, and then we drove for 30 minutes, which made us understand that it was something that was important to them. When we arrived there, we had also two cameras, and just as a playful way to get into the situation, I suggested the two users that I was gonna give them the cameras and have them put their backs to the actual structure, and we were gonna see how fast or how quick they were at finding the issue. They did that, they turned around, and within 5 seconds, they had already found the location of the partial discharge, as you can see in the picture on the right. Now, this particular case really caught my attention because they told us that they were already hearing the cracking noise. So it wasn't even something that was inaudible. And because they were hearing it, they had de-energized the entire system and replaced one, two, and three insulators. Following that, they re-energized and they kept hearing the noise. So on a different week, they prepared more components, de-energized again, and replaced the other three in the back. To their surprise, the cracking noise was still there, which represented for them an issue that could lead to a potential fire, full failure of the insulator, and of course, um, a failure on the line on the system. So when they brought the acoustic cameras and they saw that the problem wasn't in any of the six components they had already replaced, but on another one that was on the top line, which they never suspected, they were both relieved and surprised that it was right in front of them and they could never tell. That is how important it is for any type of companies that are facing either partial discharge or ultrasound related issues like leaks and friction to find issues. Two jobs, two commissions completely wasted just by not knowing where sound was coming from. Here's another interesting case that I found online where uh, trying to demonstrate how easy could be to find a leak with a listening device, they set up um, a leak of, pre-made leaks in a setup of compressed air. Then you can see the user going one joint at a time, one valve at a time, trying to find something. And so far, there isn't anything. And this is a small system. The instructor has to tell them, maybe go that way. And probably you can't hear right now, but I can hear. That final point is where the leak was. And it took him all this time going one joint, one by one, to know that the leak was right there. We had a similar situation, a similar scenario at a trade show where they had a similar setup at a larger scale. And they were doing competitions to see who could find all the leaks faster. We pull up our acoustic camera and immediately we could see all of them within seconds. I'm not talking even 10 seconds. The camera is using here different, I took different pictures showing the different visualization modes like hologram, which shows all the distribution, the sound map, which is very intuitive. One, two, three, four, five leaks around here, with the sixth one here being in the middle. And then we had, multiple spots or like these ones where the camera immediately shows where the leaks are without having to go and tapping and listening to every joint, valve, or component. That's how fast and easy it is to use. In the same manner, I invite you to think how how much it would take to use a listening only device to check for bearings, like on this conveyor system. These systems start failing and produce ultrasound by fail damage in the bearing, problems with lubrications, for instance. Try to imagine to aim with the listening gun to one, two, three, four, five, and it continues for each of them. In this facility, which was very noisy, it was a seat factory. We simply were walking the plant, looked around, and found this bearing. This is from the opposite angle, showing higher ultrasound, which is one of the fastest ways that you can identify bearings that are failing already. And you can do this from as close as I was when I took that picture, or as far as when you are in a conveyor system or belt that is bringing up material where you're standing several yards or meters away from the structure. Another interesting application that poses a lot of guessing is air tightness. So you can see in this video how they place an ultrasound emitter, shut the door, and go around trying to listen until they get to the point. Again, probably the sound isn't that clear for you. Just play that one more time. But you hear a low-pitched sound with lower frequencies. And when you get there, you hear a high-pitched sound and also higher frequencies, which tells the user where the leak is. Now, that means that you have to inspect every single centimeter of the door gasket. And if you missed one point, if you just skip by 5, 10 centimeters, you really missed the gap in the gasket where the issue is. With an FOTRIC acoustic camera, you can easily do the exact same thing, put the emitter inside, and just look at the door. And the camera will show every spot where sound is leaking from. In this case, it was pretty much the entire right section along the window, with the middle part being the loudest one. Here is just showing single point, showing one of them. Here, this one is showing the sound map, which shows that there is a serious issue all along the window. This same is used for energy efficiency in buildings. You can see on the video on the left how the emitter is outside, the door is closed, and then the camera shows all the areas where sound is leaking. And what people in the industry say is if sound can come in, air will as well. If you live in an environment with extreme temperatures during winter, all your heating energy is being wasted by places where air is getting out. And although thermography is a known technology to perform these tests, along with a blower door to uh, create negative pressure in the entire building and see where air is filtering in, this is another technology that allows you to see missing insulation on the windows or gaps on the gaskets of the windows and doors, which will ensure that your building is properly sealed to prevent energy loss. For small domestic and industrial refrigeration systems, the technique is the same, just in tone emitter. There are many different types, as inexpensive as $30, $50 or euros, all the way to a few thousands, depending on how large the enclosure that you need to fill with ultrasound is. Okay, now let's talk about stop guessing the type of partial discharge. You really know and understand that an acoustic camera prevents you from guessing where the problem is. But even other acoustic cameras that are out in the market can do that. But you take a picture and you only find out if what you saw in that transmission line, distribution line, and electrical enclosure was an actual partial discharge or if it was corona, tracking, and arcing. And if you ask me, I've been to many substations, and a lot of people say, yeah, that's corona. That's fine. That's normal. They would only care if they are identifying arcing or tracking. So I've also seen reports made with other acoustic cameras from competing brands that the picture is processed and then the report says the image or the data is inconclusive. It is recommended that you take more data. So you pretty much drove for 2 hours to visit a substation. You came back to the office just to realize that the data you captured was not good enough. Some other brands will say, yes, you can do it on the camera. But then later they tell you, but you need to be connected to the internet. Again, try to do that in the middle of a substation that is far away from any urban area. FOTRIC cameras work by using AI on the camera to differentiate and understand the type of partial discharge while the camera is aiming at it. Not even after you take the picture, it does it live. FOTRIC has taken a very innovative approach on how to do this to ensure that the camera is powerful enough to determine the type of partial discharge severity level of confidence. Here, that's why you see a 99%. Sometimes you'll see a 85%. In those cases, you might want to take a different angle, get closer, or wait for the PD to appear so that you can get very conclusive data before you report on it. Here's a very simple example. This is a windy day. One question I get often. Does it work when it's windy? Yes, it does. There might be some challenges compared to a quiet day, but you can see how the palm trees are shaking by the air, yet the camera is focused and locked on the specific location and showing that there is surface discharge occurring in that very location. The most common location to find partial discharge in transmission or distribution lines is the interface between the insulator that connects the line or holds the line to the structure and the conductor or the cable. So right here, 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 those are common places where you'll find partial discharge. Another question I get often is, does it work in noisy environments like by the roadside? The answer is yes as well. Because the camera can be fine-tuned for ultrasound, you can even fine-tune around 40 kilohertz, which is a known frequency to find partial discharge. And the camera will ignore the environmental noise and focus on actual partial discharge ultrasound noise. Recently, we performed this visit in a transmission substation in Georgia, in the US. I was really interested because from one angle, the one where you see the user holding the camera, you could see there was Corona. Again, he was like, yeah, whatever. But when you look at the second picture, he has taken an angle. And now instead of seeing the three bushings, one behind the other, he was able to see the bushings diagonally. Now he could tell that the first one, yes, had corona, but the second one, the one that was behind, had surface, which is what the camera calls tracking. Okay. Tracking, for the ones that are not familiar with the term, is basically when electrical charges start, let's say, leaking or finding a path on the surface of the insulator. The higher the voltage, the higher the likelihood of this occurring. And these charges, or well, more known as partial discharge, start breaking down the insulating properties of the insulator, causing at some point for a full discharge to occur and find ground through the body of the transformer. So this was really interesting because again, the person was trained for 30 seconds to use the camera, started walking around, and the camera showed where, what, and how bad those discharges were. Now, let's talk a little bit about leaks. What can an acoustic camera do when it comes to leaks that prevents users from guessing, spending more time at the office, and um, in bringing error into the calculation? This is one of those instances where people ask me, so how is FOTRIC camera better than others? And I'm like, just sit, let me explain. So, as you know, the FOTRIC acoustic cameras have a leak estimation tool, which allows you to get a rough estimate on the energy cost, the um, the amount of money that is costing each specific leak. I remember this very particularly because the user found it, the one that is holding the camera. He says, well, that's an $84 leak. If I stop and replace that, it's gonna cost me probably $100. That's nothing. And he was right. Sometimes you gotta pick your battles. And this gave me the insight that finding small leaks are as important as finding big ones. Because if you only have a listening device, you hear something, you say, oh, there's a leak, we have to repair, we have to fix. You may waste your time and energy fixing a smaller one where around there might be a larger one. So the cost estimation tool is a great way to prioritize your work and your repair activities. Now, the good thing about FOTRIC cameras that sets them apart from other alternatives in the market is the how easy it is to collect the data in the field. Typical brands will require user to record a sample, indicate the distance, but also indicate the pressure at the point of the leak. If you ask anyone in an industrial facility, what's the pressure at that point where I'm hearing something, they won't be able to tell you. They will say things like the compressor runs at 200 psi, and let's see, there is a gauge around here, which is 3, 4, 5 meters before the leak. That's the last gauge, and says it is down to 150. But you will never know what's the actual pressure at that part of the leak because you might have the gauge right there, but before getting to that point, it's not on the same pipeline. It has subdivided into smaller pipelines, and there is use of compressed air in different points. So it's totally a guessing game. FOTRIC algorithm to quantify the cost of leaks is different. It only requires an initial setup, which you see on the picture on the right, the cost of energy, let's say 15 euros, cents of an euro, 15 cents of a dollar, per kilowatt hour. If you're using air, just leave that as zero. Uh, there's a lot of confusion in the industry because some brands give a number to air as if air was, something you would pay for. They're they're factoring in how much it costs to pump the air, but that's already included in the energy cost of, um, the kilowatt hour they pay at the facility and some other specs. And then on top of that, distance, that's why you saw on the previous one, a stand 15 to 30 inches from the leak. And then you will also have to put the pressure, okay? With FOTRIC, all you have to worry about is the initial setup before you start, and then only the distance, because sound drops over distance. Now you can see the leak, which is, 5, 10 feet away. You put the number, the leak will be estimated considering that distance. So what number do I use for my specific power or the efficiency of the compressor? This is a rough idea of what different specific powers for different type of compressors are. So you see numbers anywhere from 15 all the way to 30. We typically leave it up to 30. If you don't know the number, that's a good number to start. But again, if you know the specific type of compressor, you can choose a number in between. This is a value that corresponds to a specific pressure, the pressures that we see here. So you might want to look at the the label on the compressor to see what is the value used there. Now, how small can a leak be for the photo camera to detect? Where the question goes along with, okay, what's the pressure, how far, how small the leak, etc., blah, blah, blah. But just to give you an idea, our most advanced model, the FOTRIC H7, can detect a leak that is half the size of human air from 30 feet away, which is roughly 10 meters, in a system that is a 50 psi, which is half the pressure, the common pressure of an industrial compressed air line. So again, half the pressure, half the size of a human air, 10 meters away, the FOTRIC H7 is able to find such small leaks. And by using FOTRIC acoustic cameras, again, you don't have to worry about what the pressure is. Sometimes, as I mentioned, you will see 120, 115, 100, 80, 80, and that's not something that you have to worry about. I've heard stories of people using other acoustic cameras or acoustic guns, finishing, creating a report and say, Mr. Customer, we have found $20,000 worth of leaks that if you fix, you could save that much money in your energy bill. And the client goes, well, how is that possible? We only pay 10,000. So the error added during the inspection for things like pressure, distance, and the general algorithm and how that algorithm was built creates a lot of error, and it has already created a known mistrust, let's say, for the technology or the specific product. When you have performed an inspection, you can take pictures of the leaks where the camera is showing the specific location with the colorful dot. It will provide information, and it can create from the software a work order ready to print to go and perform the repairs. So it shows the tag ID that you put into the camera, the building, the area, the component, which is information I'll show you how to input in the camera, the leak rate, the annual cost, and this is how you can go around the plan checking or signing that those repairs were made. So at the end, you can tell the company how much money is being saved. Photric also features a unique design, which in my opinion is my favorite. Photric Flex cameras are the only acoustic articulating cameras in the world, which make a lot of sense for those applications that I mentioned earlier. Overhead transmission lines and overhead pipelines. Most of the pipelines in industrial facility are not at ground level. They're overhead because they need to travel throughout the plant from the compressors and tanks to the actual places where they're needed. So having the ability to adjust the angle that you're observing from makes the inspections way more comfortable and easier to carry out. Talking about microphones, Photric features different models. One of the most popular ones, the H6, features 162. But we already have more advanced products like the H6 Plus, which is 234 microphones that enhances the sensitivity for small events or small issues. It enhances the accuracy on the location of those particular ones. If you look around for other brands, you will see models like this one. And this is notorious for a number of reasons. The Photric newer technology does not have the overheating issues that you will hear from any user using this type of camera. Because these cameras tend to overheat, they're required to have this dissipating fins right here. This is not decoration, this is not design, this is just to prevent the camera from shutting down for overheating, even though in some cases it actually happens. What happens with this design, and the reason this is this way, is because how data is processed. It's This technology has been out there for maybe roughly 1 or 2 decades. This technology uses most of the battery power and turns it into heat. That's why with FOTRIC newer technology, we can use smaller batteries. The operation time for each battery pack is of 4 hours versus this battery that is larger, it's probably 2 to 3 times the size of this one, runs only for 2.5 hours. You hear comments when customers compare side to side how they prefer FOTRICs because it feels less bulky. And I'm not very sure about this one. I will have to double check, but FOTRIC acoustic cameras are 2 meter drop tested, something that I hardly see happening in a unit with this design. And when it comes to price, it's a hands down decision. Customers have already proven the quality of the product, the build of the product, the performance of it, how easy it is to use. If they have used a Fotric thermal camera, they learn very fast how to use the acoustic camera, not like our competitors that have completely different interfaces, features, outlines, and everything in their thermal and acoustic cameras. So when we get to that point, to the point of the price, and they have seen all the benefits, it's very easy for them to make a decision and move towards a Fotric acoustic camera. Another interesting thing that you must be aware of is that some competitors sell the same product with different names and different software inside at different prices. So the one on the right is $21,000. The one on the left is $28,000. And you ask, what's different? And the answer is nothing. Same amount of microphones, same components, everything. All the hardware is the same. All they did was like cripple the features on this one and allow full features on this one. This does only partial discharge. This does only leaks. They also have a model where it only works for air leaks and another one for gas leaks, as if it was a different thing. And then the one that can do both. So with Photric acoustic cameras, you're able to do all of it in any of our product models and get higher sensitivity with higher microphone count while detecting the type of partial discharge live without connecting the camera to the internet or going back to the office for cloud service. Another interesting application that I really like that prevents the guessing during an inspection is how you can determine whether there is partial discharge inside an electrical enclosure. When electrical discharge occurs or partial discharge occurs inside an enclosure over time, those discharges start ionizing the air inside. By doing so, they create a more conductive, let's say, microatmosphere, and the ozone starts reacting with the material of the insulating components to create nitric acid that in turn degrade the insulating properties even more. This was a food sign like those that you see on the road when you're traveling, with I don't know, Texaco or McDonald's, those big light signs. We're just passing by, grabbed some food, and then decided to take a look. And effectively, there was tracking or surface discharge coming from that box. Imagine an electrician opening this box without knowing there's tracking inside. The first thing that's going to happen is that an arc will jump onto him because he would be, if he's not wearing the right PPE, especially, he would be the shortest and less resistance path to ground. You can also identify whether there's partial discharge in electrical enclosures through vents. Here, there's no vent, just the gaps in the gasket. Here, there's a vent, and then you can see there's arcing occurring inside, 99% certainty. These graphs that you see here, by the way, they are the PRPT graphs, not something that you need to learn or identify by yourself. They're just for confirmation of experts. The camera is already doing the AI, and this is where you direct your attention when you're performing a scan. Because this feature is available in FOTRIC Acoustic cameras, they are a great tool for mixed cameras. When you're doing a thermal imaging scan of an electrical enclosure, you want to be sure that there is no arcing occurring inside, because the moment you open that enclosure, there could be an accident, an arc flash explosion. So what many of our users in different countries, but especially in the US, are doing is they're using their mix camera to check through the seams of the enclosure, switch panels, distribution panels, transformer panels, etc. They check before they open. In this case, you see it says noise, so that is probably reflection of the voice or something that was there. But you could also find this. You could see every dot highlighted with the purple arrow is showing a place where the sound is coming out of the enclosure. Okay. And the camera is telling you there is arcing, which is floating discharge. There's arcing in there. Do not open. Do not dare if you want to spare your life. So the features that you see on standalone acoustic cameras are available on our mixed products, the articulated and pistol grip mixed cameras, which are a great tool to find different types of issues in different components of the same asset. Here's one example. There's a hotspot on the connection on the face of the left side, while there is floating, kind of like little arcing on the right side face of the same line. You don't see any heating on the insulators. One, two, three, no heating whatsoever. But yet there is some sort of arcing. This was a very misty night. I went back uh, sometime later, and now I was seeing actual heating on the insulators. This is not a regular heating. You can see there are specific sections of the ceramic insulator that are hot. Here's just in a specific part. This one you can see that is in the back. Here you can see that is all along horizontally. So these heat patterns are um, common for tracking events. And then you can see here that now the acoustic camera is confirming the problem, but indicating the cause as well. So tracking is creating this type of issue. It's not, insulating damage for water intrusion. It's not, I don't know, something else. It's literally the phase is tracking, is finding ground to the structure of the pole and creating a heat signature in there. You may be wondering, okay, how can a camera do all of that in one single battery? Because as you see here, this is just one single battery and the camera runs for 2.5 hours to 3 hours, which is the same as just the acoustic camera in our competitors. How can FOTRIC achieve that? The reason is the world-class components that we use in how we build our product. These are top of the line from all over the world to make sure that we process all of that. And remember the FPGA by Xilinx. This is at the core of how FOTRIC processes data without using a lot of power. And you might think, Fernando, why are you sharing that? Your computers are going to copy it. Well, working with FPGAs is a way harder approach to data processing. These are, in a way, simple components, but they are very difficult to program. And that's where FOTRIC R&D engineers have excelled and have taken years of advantage to our competitors. And things like a Qualcomm high-end processor allows for fast performance of the unit and processing of images that have been taken. I would like to close with some additional features that make life easier in the field, which is all what FOTRIC is all about, like annotation. You saw the first video that I presented with someone holding a notebook and taking notes of whatever the guy was listening to. With FOTRIC cameras, you can take the picture. You can see the cost of this leak is $2,400 roughly for that particular leak. And instead of taking a separate, companion device, a tablet, a smartphone, or a notebook, you can simply set up the camera with preset annotation fields and drop-down menus. So the moment you take the picture, the camera will show this on the screen. You will choose from your own drop-down menus, and that way the information will be saved onto the image and from the image into a report. So how much would I need to spend in other brands if I want to achieve this much? Well, if you want to do the comparison, go and check how much is a 640 by 480 infrared camera. How much is it to have a software every year, the payment every year to get to customize and do reports, because there are softwares that are free, but you cannot customize anything. See how much is it to get a camera that can do leak cost estimation with partial discharge identification capabilities, because remember that some can do leak, some can do partial discharge, but if you want to do both, you might need to go up in price. And if you can do route at all, which is a topic for another webinar. And FOTRIC can now put those two technologies together in one single device and help you and your users save time and a lot of money. Okay, I believe we have come to an end. Once again, thank you very much for joining us. And remember to stay tuned for future webinars. Some of them will be for everyone, they will be open for your customers so you can invite them. Some of them will be like this. With any further ado, we want to wish you a good rest of your day and see you on the next one. Thank you.